Hello, ladies and gentlemen. We are here to talk about rotations in the coordinate plane today. And so let's jump right in and talk about this from several different standpoints. And the first one being, I want to talk to you about what happens when something is rotated. Okay, so here I have an arrow and it's drawn on a piece of transparency paper. You could see, and I'm just laying it down on top of my coordinate plane. And this is going to help me visualize what's happening. And if I rotate this little arrow, and I'm going to hold my pen or pencil here, right on top of the origin to try and hold it still. So I'm rotating around the origin. As I rotate, it starts pointing in different directions. That's the first thing to realize. Remember that a rotation changes the orientation. Orientation is like which way it's pointing. So like the arrow points up here, if I rotate it 90 degrees, which is the same as 1/4 turn, now it's pointing to the left, another quarter turn, and it's pointing down, and then another quarter turn, let me move my hand, you can see it's pointing to the right. And then all the way back around, it would be pointing up again. And it's true whether it's in the coordinate plane or not, that if you turn something, it's no longer facing the same direction it was to begin with. So let's look at another one, and this time I have a little post-it note, and I'm actually going to see if I can use a safety pin here if it'll work a little better. And what I want to emphasize to you here is right now, the little post-it note, it's a rectangle. The rectangle is wider than it is tall. It mostly goes left and right. It doesn't go up and down very much at all. If I rotate it 90 degrees, that changes. Now it's much more about the up and down than it is the left and right. It's much taller than it is wide. Rotate it another 90 degrees. And now it's back to being wider than it is tall. And finally, here we are in the fourth quadrant. It is taller than it is wide. And then let's get back to home. So every time it rotates 90 degrees, which is the bigger direction kind of changes in terms of left and right or up and down. So that's just something to be aware of. Okay, so here is another rectangle, and I've labeled this one, and I labeled it so we can watch the points. We know that it's taller right now, and so it's going to be wider when it changes, when it turns. It's going to be more sideways than up and down. But the other thing to notice is that it used to be that A was the upper right corner. Now A is like the upper left corner. And if I keep going, A becomes the lower left corner, and so on. Now, when that matters more is when it's something that's not like a rectangle, but is instead like a square. Okay, actually it matters both with both rectangles and squares, is that in this case, and let me come back to what I mean by that. One thing that matters more with squares is where the shape is. I mean, the shape looks exactly the same. And so you might have thought, if you did not see those points, you might have thought that all I did was slid it over. And it was just a translation. But if I did that, then the orientation would not change. Q and R would still be on the top. T and S would still be on the bottom. Another thing you might think happened if you didn't know what point went where is you might think it was a reflection over this line where it would look just like this. All right, but notice the Q would stay closest to the line of reflection, which is in this case the y-axis. The Q and the T would stay closest, and the R and the S would be over there on the left, whereas the R and the S were originally on the right. So the orientation would change in a different way than if we rotated. If we rotate, now the Q and the R that were at the top, now they're on the left. So sometimes some figures like this square, you really have to know where individual points are to know whether you have a rotation or a reflection or a translation, because it matters. Okay, so the next thing we're going to do is we're going to look at a specific point and how to rotate a specific point without using a rule. So in other words, figuring out rules by knowing how this is going to move as we rotate it. Rotations can be one of the harder things to visualize, to just get a feel for what it looks like. So usually if we use any kind of visual way of rotating something, we're going to break it down into two parts. One is the horizontal part or horizontal component, and the other is the vertical component. So in other words, from 0, 0 To get to that point, I'm going to figure out that I have to go 5 units to the right and that I have to go 3 units up. And since I used green, I'm going to let that be a stem and make a little flower out of this. Okay, so let's look at different ways I can think of moving that. One is, let's focus on what happens to the orange, to the horizontal part, and what happens to the vertical part. So I'm going to take a marker and I'm going to trace that. Oh, that's my marker with my sticky note. Let's go ahead and trace right there and say, okay, here's the orange part. And see what's going to happen if I turn this, and I have too many things in front of me here. I'm having to move everything. Remember that black is right on top of the orange part. That black part, the orange part, is going to go from being side to side. It's going to go up and down, just like we talked about the rectangle doing. So this horizontal line is going to become a vertical line. So instead of going 5 to the right, I'm going to have to go 5 up. All right, so I'm going to go ahead and show that. Up 1, 2, 3, 4, is that the 5 here? There we go. And then I'm going to do the same thing again for that little vertical line, like a flower stem. Okay, so here we go. 3 up. When I rotate that vertical line, it becomes a horizontal line. So it's going to be like that. So my 3 is actually going to be to the left instead of up. This is if I do 90 degrees. And if I keep going, it's going to keep changing in that way. I'm just doing 90 degrees at first. So this point would go up there. All right. Now, 2 other ways of representing the exact same thing, which is really just talking about how the horizontal changes, how the vertical changes. One is I'm going to label the directions here. This is going to be right. This is going to be up. This is going to be left. And this is going to be down. And I'm going to say, okay, my original point was right 5 and up 3. So right 5, up 3. So I have a description of how to get there to begin with before I change my pre-image. And then I'm going to think about, okay, if I'm rotating 90 degrees, here's right. What is 90 degrees from right? Notice that I'm always rotating the same way. The direction I've been rotating is counterclockwise. When you're doing rotations, if they don't tell you which way to go, it's always counterclockwise, which means keep going all the way around like this. If they told you clockwise, then you would go the other way. But if they say counterclockwise or they don't say anything, you go counterclockwise. Counterclockwise is like your default. So 90 degrees from right is up. So I'm going to take this and I'm going to say, okay, that's going to be up now. This is the same thing that happened to that orange. Then up 3, okay, here's up. 90 degrees from up is left. So that changes to left if I rotate 90 degrees. So up 5, left 3, which is exactly what we did. Last way I'm going to point this out, and all of these are interchangeable. You don't have to understand them all. One of them might work better for you than others. Another way I've had students enjoy doing this is with compass directions. So this is north, south, east, west. And then I think about how to get to the original point, and I say, okay, I go 5 east and 3 north. 5 east, 3 north. And then I say, well, if I'm going 90 degrees, east becomes north. If I'm going 90 degrees, this north becomes west. So getting my new point will go 5 north and 3 west, and that will get me to my new point. Any of those can help you. And if we were talking about 180, 180 from east is west. 180 is like 90 twice. Whenever you have a coordinate plane, each of these sections, each of these quadrants is like 90 degrees. So it's like a quarter turn, 90 degrees, is going through one quadrant. If you're going through 2 quarters of a turn, which is 180 degrees, 90 plus 90, that's going halfway around. 3 quarters of a turn would be down here if I started over there. If I wanted to know what 3/4 of a turn or 270 was from north, I would go 90, 180, 270, and I would say, well, that's east then. Okay, and again, I'm always going counterclockwise just because that's our default. But sometimes you might have to go clockwise, which just means you turn the other way. Okay, so now we're going to look at it a little bit more in terms of not the visual of what it looks like and going up and down and left and right and all of that, but in terms of the rule. This is kind of a way that works without a rule, but it also works for the rule. Let me just explain what I mean a little bit better. This is always true, that if I am rotating for every 90 degrees that I have turned, and when you are turning in the coordinate plane, you pretty much will only turn in multiples of 90 because you'll turn in quarter turns, 90, 180, 270, okay? For every 90 degrees that I turn, the X and Y values trade places. This is completely ignoring their signs. It doesn't matter if they're positive or negative right now. You're just looking at the number values and saying, okay, which one's going to be first, which one's going to be second. Then, for the signs, you figure out the signs by figuring out which quadrant it lies in at the end. Okay, let me give you an example for our little flower. Our little flower started out at the point 5,3. If we turn 90 degrees, we just read for every 90 degrees turned, the numbers are going to trade places. So that means instead of the 5 first and then the 3, that tells me the 3 is going to be first and then the 5. Now, this is not the final answer. I then have to go to this part and figure out my signs. For the signs, I have to look at which quadrant it's in. All right? Every single quadrant has specific sign values that work in that quadrant. That's true for all points in that quadrant. So let's look at those for a sec. Every single point in the first quadrant, which is right over here, has a positive X and a positive Y because you go to the right and up, and they're both positive. This quadrant, you go to the left, which is negative, and then up. So in quadrant 2, we have a negative for X and a positive for Y. Every point in quadrant 3, I have to go left and down to get there. Left is negative for X and down is negative for Y. So everything in quadrant 3 has a negative X value and a negative Y value. And finally, in quadrant 4, I go right and down, always from the origin, right and down. Right is positive for my X value, down is negative for my Y value. So these are the signs of the quadrants. So if I know which quadrant my point ended up in, and this is not actually the same drawing I showed you guys, sorry. There we go. Let's go with the flower. If I know what quadrant it ends up in, I know what the signs should be. Negative, positive, because it ended up here. So the 3 is going to be negative and the 5 is going to be positive, and that's my answer. So let's do that with a couple of other ones. All right, if I start with the point, let me get you smaller. There we go. It's mini. Let's say I start with the point -2, -5. And I tell you I want you to rotate it 180 degrees. Now, the first thing to know about that is if you are going 180 degrees, it doesn't matter which way you go. Because if I go 180 degrees like this, I'm going to end up in the first quadrant. If I go 180 degrees like this, I'm going to end up in the first quadrant. 180 degrees is halfway around a circle. If you go halfway around a circle, you're in the same spot. It doesn't matter which way you went to get there. So we don't ever say clockwise or counterclockwise with 180 because it doesn't matter. So before we worry about this, though, before we worry about the final signs, rotating 180 tells me for every 90 degrees I turn, my X and Y are going to trade. So right now, the 2 is first, the 5 is second. 2, 5. Okay, I made little interactive numbers to make this a little more obvious. The 2 is the 2 is first, the 5 is second. For every 90 degrees we go, so I'm going to say 180 is 90 degrees twice. So the first time they trade, and then again they trade. So after 180, they're back in the same position with the 2 first and the 5 second. All right, so it's going to be somewhere up here with the 2 first and the 5 second. So 2, 5. What are the signs going to be? Well, this is the first quadrant, and everything in the first quadrant is always positive. So it's going to be positive 2, positive 5, and that's my answer. Next one, this time we have the point -2, 3, and we're being asked to rotate 90 degrees. This stands for clockwise. If you see CW, that's clockwise. If it was going to be counterclockwise, it would be CCW, stands for counterclockwise. Okay, so this says clockwise. So since it tells me to go clockwise, that means I'm rotating in this direction. All right. Now for every 90 degrees, the numbers will switch. Okay. So we're rotating 90 degrees, so that means the number order is going to switch, which means the 3 is going to be first and the 2 is going to be second. Last time they ended up switching back after that because we did another 90 degrees because we were doing 180. This time it's only 90. So the 3 is going to be first and then the 2. It's going to go one quadrant over because 90 is a quarter of a turn, one quadrant, and it's going to be 3, 2, and it's going to stay positive, positive because those are the correct signs for the first quadrant. All right, let's do another one. Okay, so this one just says rotate 270. So how am I supposed to know which way to go? If it doesn't say, remember, that always means counterclockwise. All right, so it doesn't have to say counterclockwise. You're going to go counterclockwise anytime it doesn't say clockwise. So even if it didn't say that, we would still know that we're going to go counterclockwise if it just said 270 and that's all it said. All right, so let me get my little interactive numbers here again. At the beginning here, the 2 is first and the 4 is second. And for every 90 degrees we go, we're going to trade them. So 270 is 90 once, 90 again, and then 90 one more time. 270 is 90 times 3. So I'm trading them 3 times, which means they started out like this. They traded for 1 time, 2 times. They were back to where they started. 180 is always back to where you started. And then 1 more time. So the 4 is going to be first, and the 2 is going to be second. Now 270 is 3/4 of a turn. So every time we do a quarter turn, we move from one quadrant to the next one going in order. So that's 1, that's the 90, and then down to here would be the 180, and then down over here. So we're going to end up in this quadrant right here. The signs in this quadrant right here are positive and negative. It's the fourth quadrant. So my 4 is going to be positive, and my 2 is going to be negative, and it's going to end up right here. Okay, last one I want to do, we're actually going to do all of them, but this time we're going to do them as a rule because I want to show you how you can use this technique to find the actual coordinate rules that work. All right, so let's take, for the rule, we have to always start in the first quadrant. So let's just take a random spot in the first quadrant and call it X and Y. And for the rule, we're just going to treat them like they're both positive, okay? If I want to rotate 90 degrees counterclockwise, that means going this way. It's going to end up in this quadrant. Remember, every time we go 90, they trade spots. Another thing we have to remember, though, is in the second quadrant there, it's negative and then positive. So this should be negative. Then if I go another 90, down here, they trade again. This is the quadrant, though, where everything is negative. And then if I go another 90, they trade again. And this is the quadrant where it's positive first and then negative. So it's like that. So these are actually a visual representation of my rule. Let's go ahead and write that down. Okay, so 90 degrees counterclockwise is what we did first here. We went from XY to negative YX. Okay, 180 was this and then this. We went from XY to negative X, negative Y. And then 270 is all 3/4 of that turn. So 1/4, 2/4, 3/4. 90, 90, 90 is 270. and we went from x, y to y, negative x. All right, the only other thing we need to say about this is what about if I had turned the other way? These are all going counterclockwise. You got to make sure you know when you memorize rules, you got to make sure you know which way it's going. So these are all going counterclockwise. Well, 90 counterclockwise, here's 90 counterclockwise, gets me to the same place as if I went 270 clockwise. 270 and 90 together is 360, which is all the way around a circle. So if I have 1/4 turn in one direction, that's the same as going 3/4 of the way around the other direction. So this is the same as 270 clockwise. And the same thing happens down here. That's not a good color, I'm sorry about that. That definitely did not get much better with trying. I tried to go over it with a couple of things, but that did not help much. So let's switch pens here, and down here, 270 counterclockwise. That was going all the way around, 3/4 of the way around. Going 3/4 of the way around counterclockwise is the same as if I just went 1/4 of the way clockwise. So 1, 2, 3/4 of a turn this way is the same as 1/4 turn this way, and a quarter turn is 90 degrees. And that's all you need to know about rotating about the origin. Okay, so these are all about the origin. You do have to know for sure that that's your center of rotation. If it's something other than the origin, that gets a little bit more complicated. Hope this helped. Thanks so much for being there. Bye-bye.